Here's an example of solving a system using substitution. The system is x plus y equals 6 and 5x plus 5y equals 10. So first, we're going to solve the first equation for x. Since looking at the 2, that would be one of our easiest options to get a variable alone since it's not automatically alone now. So we'll subtract y from both sides, making it x equals 6 minus y. We're then going to substitute 6 minus y into x of the other equation. So it's no longer 5x, but 5 times 6 minus y plus 5y equals 10. After distributing, that would give us 30 minus 5y plus 5y equals 10. And negative 5y plus 5y is going to simplify to 0 or cancel out, leaving us with 30 equals 10. This is definitely false. So since 30 equals 10 is a false statement, the system has no solution. We can't solve for a variable. Our answer then just becomes no solution. So when your variables cancel out, when you're trying to solve using substitution and you end up with a false statement, we can always conclude the answer will be no solution. Let's look at this example now and see what happens. Again, we're going to solve the following system trying to use substitution. So x plus 4y equals negative 3 and 2x plus 8y equals negative 6. Now looking at this, the first equation solving for x would be the easiest, fastest way to get a variable by itself. So we'll subtract 4y from both sides and get x equals negative 3 minus 4y. We'll substitute that into x in the second equation, making it 2 times the quantity now, negative 3 minus 4y, plus 8y equals negative 6. We'll distribute to get negative 6 minus 8y plus 8y equals negative 6. And negative 8y plus 8y is going to simplify to 0, cancel out, leaving us with negative 6 equals negative 6. This is always true. Negative 6 does equal negative 6. So now, since negative 6 equals negative 6 is always a true statement, there are infinitely many solutions to the system. So we can conclude anytime the variable disappears or cancels out and we're left with a true statement, it would always now the answer be infinitely many solutions. We now have these two special cases when trying to solve for substitution.